So in the previous class, we started evaluating properties. We started to find properties. And the one thing that we learned about it was that if we know two properties, two independent properties, we can find other properties. So now continuing the same thing, that in this question we have to locate that which state are these numbers, and we also need to find an unknown property. So in part A of this question, we know temperature and we know specific volume. So if we draw a TV diagram, if we draw a TV diagram, it would look like this, and a line of constant pressure would look like this. Now if we consult the tables at 140 degrees Celsius, so now let's look at the tables. Now table A2, let's go to A2, which is a temperature table. Now we are given a pressure of 140 degrees Celsius. A pressure of 140 degrees Celsius, the corresponding pressure is 3.613 bar. I want all of you to note it down, 3.613 bar. And the specific volume is between 1.07 1.0797. So notice the top of this column. The top of this column says that Vf is multiplied by 10 raised to power 3, which means the entire column is multiplied by 10 raised to power 3. So Vf is actually 1.0797 into 10 raised to power minus 3. So copying all of this over here. So the pressure, the line of constant pressure was 3.613, and the Vg value from the table was 0.5089. Vg value was 0.5089. So we have V of 0.5 and a temperature of 140 degree Celsius. So if this temperature is 140 degrees Celsius and we have V of 0.5, so which means that we are in the mixed vapor region. We are just before the saturated vapor line, or the value of V is less than Vg. Now we are asked to find T. I think so this is a typing error. So the temperature they have already given us. So temperature is 140 degree Celsius. Now part B. Pressure of 30 megapascal and a temperature of 100 degrees Celsius. So it's a very high pressure. So if you just look at these numbers, so if this pressure was 1 bar and this was 100 degrees Celsius, then it would have been boiling water. Now this pressure is very high, which means that this is not boiling water. It might be liquid or it might be solid. So again, let's draw the TV diagram for part B. So by drawing a TV diagram, line of constant pressure. So if this is 100 degrees Celsius, then this pressure is 1 bar. So 1 bar is, and to be exactly, it is 1.0 14 bar. Now this 30 into 10 raised to power, this is so now this line 30 megapascal, what would, I'm sorry, line of constant pressure, line of constant pressure looks like this. So it is upward sloping, and so this line is of 1.014 bar. Now line of 30 megapascal. 30 megapascal is how many bars? So it is 300 bar. The line of 300 bar would look something like this. Now 100 degrees Celsius and 300 bar coincide in this region. So it coincides in the liquid region. So now coming back to the table. So this table A2 is mixed vapor. Table A3 Table A3 is again mixed vapor. Table A4 is superheated water vapor. Now we have table A5 is compressed liquid water. So we are now, if you go down and if you keep on going down, this bottom right table is 30 megapascal. You can see 30 megapascal, and we are looking for 100 degrees Celsius. So 30 megapascal and 100 degrees Celsius, the corresponding value is this 1.029. 1.029 into 10 raised to power minus 3. So V of part B is 1.029 into 10 raised to power minus 3 meter cube per kg. Now part C, 10 megapascal and 485 degrees Celsius. So first we draw a TV diagram, then line of constant pressure. Now we are given 10 bar and 485 degrees Celsius. So going back to the tables, 10 bar, so I was going back from compressed liquid table, and table A4 was superheated vapor. So here you can see that we have in superheated table we have pressure of 10 bar and we have temperatures, the leftmost column, 440 degrees Celsius and 500 degrees Celsius, which means that this point 485 lies in the superheated region, because the pressure and the temperature exist in the superheated region. We would have to interpolate. So we would have to interpolate this. So suppose right now I was going back from compressed liquid and to superheated region and I stopped here. Suppose we don't stop here and we keep on going back. Now 10 bar, this is the mixed table A3, this is the mixed vapor region. Now if we look at 10 bar, the corresponding temperature is 179.9. So if this is 179.9, this pressure is 10 bar. But in our question we are given 485 degree Celsius. So 485 degree Celsius and 10 bar coincide in the superheated region. So you can see the TV diagram. So first I draw the points of the saturated liquid region, and then I find what does 485 degrees Celsius and 10 bar look like. Now if we copy, so if we copy from the tables, now going back to the superheated region, So 10 bar. So 10 bar, we need to find the specific volume at 485. We are given the specific volume at 440 degrees Celsius. So 10 bar, so at 10 megapascal, 10 megapascal, at 440 we have 0.02911, and at 10 megapascal at 480 we have 0.0316 specific volume. So at 10 megapascals. So from the tables, what we know is that when the pressure is 10 megapascal and temperature is 440, and 480, the corresponding sorry 4 temperature is 480 and 520, the corresponding specific volume for 520 is 0.03994 and 0.0316. So these are the corresponding specific volumes. We need to find the specific volume at 485 degree Celsius, which means that we have to interpolate. So we need to find what is the specific volume at 485 degrees Celsius. So let's say it is V, specific volume. So we need to assume that the specific volume between the 2 points changes linearly. So we need to equate the slopes. So how would we do that? So V minus 0.0316 into 10 raised to power minus 3 divided by 485 minus 480 and then 0.03994 into 10 raised to power minus 3 minus 0.316 into 10 raised to power minus 3, 520 minus 480. So we get a specific volume of 0.3189 meter cube per kg. So we did an interpolation. Interpolation is that finding middle values between 2 points by assuming that the trend changes linearly. In actually, in actual thing, the trend does not change linearly, but but when we are doing calculation by hand, there are certain limitations. Now the last part, a temperature of 80 and quality of 0.75. We need to find pressure and specific volume. So first drawing the TV diagram, line of constant pressure. So they have given us that the temperature is 80 degrees Celsius and quality is 0.75. A thing has quality, which automatically means that it lies in the mixed vapor region. So we need to consult the mixed vapor region tables. So now going back to the tables. So this is the superheated table A4. Going back now, table A3 mixed vapor region. This is a pressure table. We are looking for temperature table because we know temperature. So at 80 degrees Celsius, in the mixed vapor region, the pressure is 0.4739 bar. So the pressure is, the first part is 0.4739 bar. Then we need to find the specific volume. So the formula for the specific volume is V equals Vf plus X into Vg minus Vf. So Vf and Vg we know from the table that Vf is 1.0291 into 10 raised to power minus 3 and Vg is 3.407. So if we substitute all of this in the equation, into this equation, so we would obtain the value of specific volume to be 2.55 meter cube per kg. So in this class we learned a very important topic of how to find the state of a system and how to find the unknown properties. I hope you found today's lecture to be useful. Thank you.